first like to start off by thanking the council for the recognition of 8 Spruce Street and the privilege of being here today. And for the other regional winners, congratulations. And Adrian, congratulations to you. That's an amazing body of work. So our presentation today is going to focus on the curtain wall. There's a lot to talk about on Beekman, which was the original name for those of us who spent the last 6 or 7 years on the project. But now it's formally called 8 Spruce Street. So speaking about the curtain wall, John Barrows will do the nuts and bolts, if you will, after my brief view from the developer's point of view. So before we get there, I'm going to take a few minutes to tell you or show you of how we got here. Okay, where is it? That's an aerial view. The project is located in Lower Manhattan. It's on the northern edge of the financial district, adjacent to City Hall and the Brooklyn Bridge. And it is a few blocks from the World Trade Center site and adjacent to the Woolworth building. This is a skyline view. You can see the impact that the building already has made in Lower Manhattan. Some more context, as I mentioned before, it's north of the towers and the canyons of Wall Street and adjacent to the Woolworth building. Okay, so how did we get here? As a developer, we have to figure out what it is that we want to do and go ahead and do it. Well, the obvious is first securing the land, but what may not be so obvious to some of you is managing through the complexities of the New York City zoning regulations, which do dictate exactly what we could build. Well, we analyzed what we felt were the key factors in establishing exactly what we should build. In 2007, those key factors to us was a looming credit crisis, which meant the absence of debt financing, the construction costs going through the roof, and the changing market conditions, which seemed to change at a radical pace almost at a day's notice. So we made the decision to build a residential building and to engage Frank Gehry. So a residential building. Many still ask, and many have always asked, why not condos? Well, to us, as an owner-developer, it was simply too risky at the time. And what really launched our decision to go to 100% residential rental, which it was not an easy decision, was the influx of over 10,000 condo units in 2006. And absorbing those into the New York City pipeline, even at a normal rate, would have taken about 6 years. And the bottom line, though, as far as city, we are a long-term holder of real estate. We're not just a developer. We don't flip properties. So this is where we are today, the program, the building program. We maximized FAR. We built as high as we could, but still being driven by the limits of the FAR. The building itself is 1.1 million square feet. The residential portion has 903 total units, again, 100% rental. It's 870 feet tall, and it's 76 stories. The residential portion is anchored by a 6-story podium. In the 6-story podium, we also developed and built a New York City public school, a 630-seat public school. The doctor's offices, street-level retail, and below-grade parking for 175 cars. So here we are today. This slide, this photo is of the tower's lobby and building entrance. It's a good way to segue, as Craig Webb, partner of Gehry Architects, is out there somewhere. It's a good way to segue into the entrance of the process. Models. There were a lot of models. Okay, with Frank, we knew, obviously, that he worked with state-of-the-art 3D technology. But what we came to find out pretty quick is that all comes from literally building models. We have photographed only 12 of the 70-some-odd models that were literally built, starting from the massing model up to where we are today, which is on the lower right. And along the way, the envelope, as you can see in the curtain wall, certainly was taking shape Not necessarily where we ended up, but certainly was taking shape. Designing outside in and inside out. And I have to tell you, sometimes I really thought we were upside down. So with Frank Gehry came the complicated and amazing curtain wall, free-moving curtain wall. But with a residential building comes a seemingly immovable standards for unit layouts and unit mixes. We are a developer. We have to maintain those standards. To me, this momentum of these opposite forces, which eventually melded together as one, but they did stay distinctly apart. And there was a bit of serendipity, I thought, where each factor benefited from the other. What do I mean? Well, this is the prime example of that. Undulating exterior equals unique layouts. We could actually flip that. We can say requirements of unit mixes drives the fenestration, drives an even more undulating exterior. So this is the most evident example of what I said before, the one benefiting from the other. Every floor plate on the residential structure, almost 70 of them, is completely different. That allowed for a unique layout for the actual residential units. So we have 903 residential units. Of those, over 350 are uniquely unique, which in our business really accentuated the lease-up. But by the same token, every residential unit maintained its standards for a quality home. Okay, developer and architect collaboration. There's no doubt in our world, this is key. I think what's missing here, though, in this slide and my slide, is the collaboration of two other forces, which are the contractors and the engineers. I think the combination of all four, the developer, the architect, the engineers, and the contractors, is what was the key element to the success, in my opinion, of this building. Project team. These are the major members of the project team. Gehry Architects, of course. I'm going to highlight only a few that is appropriate for this presentation. Gehry Architects, our structural engineers, WSP Kansas Scenic, our systems and MEP engineers, JB&B, Jarvis Bauman Bowles, our envelope and curtain wall consultant, Heitman Associates, our construction manager, tenacious as ever, Chrysler Borg Foreman, our wind engineering consultant, Roland Williams, Davis, and Irwin. And Dr. Irwin, I know you're out there, and I apologize for misspelling your name. This is actually not my slide, but I did catch the error. We couldn't fix it. It was already embedded. That should be an Irwin with an I. Superstructure concrete, Sabara Construction. One of only two, I believe, concrete contractors in the city of New York that is not only able to build an 870-story all-concrete building, but embed the 12,000 or so embedments into the edge of slab, and of those have only four that I believe that exceeded the tolerance. I purposely skipped one, Permis Lisa North America, who I'm sure is is very well known, certainly in this community. I'd like to personally thank Permis Lisa for their efforts in this building, because I believe that without their input, Mike Budd leading the team, we wouldn't be where we're at today. So that's my brief presentation. Frank couldn't be here, but I am going to introduce you to Frank. I'd like to say a few words, and then I'm going to pass the baton, so to speak, to John Bowers, who's going to take you through the actual nuts and bolts of the design process.
What I wanted to do was to resurrect the bay window, which there are buildings around New York City. And when you walk to a window that's flat, you're there, and you can see on either side is a big window. But if there's a bay window, you walk 2 more feet forward and you're in outer space, so the window surrounds you. And that experience on the 40, 50, 60 floor is unique. There's nothing like it in New York.
introduce John Bowers, our partner at Gehry Architects.
Thank you, Joe. And I'd like to say a couple of thank yous right off the bat. Thank you to the council for recognizing our project. Frank is currently traveling for the next couple of weeks, and he passes his thank yous along as well. So it's great to be back here. I'm going to give a little overview of the project for those of you that maybe haven't seen the project or know much about it. It's 876 feet tall. You can see it's broken into 5 zones, starting with the podium, which is a masonry element with the school as the primary tenant. And then there are 4 sections of the tower that we've broken up, largely with zoning and mostly driven through with the unit floor plans, tapering as it rises to the top floors. The structural model, which is a reinforced concrete structure. You can see with the 3 bands, the one at the 6th level, the one at 38, and the one at 76 are the major outrigger walls that connect all of the perimeter columns and the interior columns at those transitional floors. Those are our major structural transitions dealing with the steps of the massing. The program Joe kind of hit, but it really was driven, the shape by the units and the layouts. And you can see the T plan itself was really kind of derived from achieving 6-corner apartments, which was a big plus. The site itself is virtually free of large structures around it. So the view around the project is just amazing, and I'll show you some slides here in a second. This is a larger floor plate. This is the 9th floor shown. You can see in the center there are 2 cores. There's a low-rise core in the northern wing, and then the high-rise core in the central part of the intersection of the T. And then the units, as they are spaced around the building, alternating between the orange and the white. This floor plate has 20 units per floor. And moving to the upper floor plate, the smallest floor plate is about 10,500 square feet with 8 units on it. And these range roughly from 800 square feet to about 1,600. The 3-bedroom in the north wing is the largest apartment. Here's a little animation that I would like to go through. The unique feature with the wall and the interface to the apartments, it'll zoom in here in a second. That starts, and you can see the floor plates on the right-hand side. Obviously, it was a key feature in the apartment and achieving what Frank set out for with the bay windows. Each floor is absolutely unique. It was a challenge in terms of the documentation and pulling all of this together, and I'll get into a little bit of that, how we were able to control that, and how we were able to use our delivery system to kind of pull this together in collaboration with a very strong team. Let's see. Here's kind of finished product. This is a model apartment. This is, I believe, in the 50s. East facing with a bay window on the left-hand side. You can see the Brooklyn Bridge and the East River in Brooklyn off to the distance. Another shot here looking north, and you can kind of see my point about the views. You essentially have all of Midtown in your living room. Both rivers, each side, the East River and the Hudson River, flanking Midtown, which is just incredible. The other part of this is looking towards the west. You can see the new tower being constructed in the Woolworth building in kind of closer proximity. So I'm going to talk and touch base about the process, how we got through this, and then eventually documenting it. As Joe stated, this was really the first study model with this scheme, and there was approximately 70 study models that we went through, mostly derived from programmatic changes, condominiums, all rental schemes, etc. And we ended up settling on this direction. We start with the paper model first, obviously. What this is essentially our digitized process. Once we have certain direction in terms of the design and how we want to move it forward, we're able then to digitize some of the paper surfaces, bring that into the 3D computer model, and then really the process begins from this point forward. Here's kind of a first pass at some of the surfacing, the interpretation in the 3D model from the paper model, and it continues through the various faces up along the side of the building. Surfaces then become refined in terms of their geometry, their shapes. Eventually, they come to a conclusion, placed back onto the model, and then punched that ends up being coordinated with the apartment layout. So really, it is kind of an inside out, outside in. They both drive one another. Here's a shot of the final surfacing model that we ended up going to construct from. This is the north face. This is facing towards Midtown. And then the final installed view from the street level. So this part here is really where it gets fun. And as our exterior curtain wall contractor mentioned several times, that we were pushing the fun meter several times. So we started internally with the computer model, studying various components in the wall system, how it could go together, then going back and forth to paper models. This model essentially represents ways of how we thought before we really had outside input into the technical development of the wall system. This gave us an opportunity to really vet it out before we release that type of information out. At this point, we'd spent several months in the design phase, and we tend to accelerate the level of detail and information earlier on in the process that helps to make us a little bit more intelligent about where we're headed. At this point, we had a package along with Forest City and KBF. We were able to prepare an RFP. Went out, 3 different vendors, Permasalisa was selected, and then really the process begins. This slide is very key. After several work sessions, this is a little bit of a summary showing the slide on the far left is the curtain wall units. We were able to basically break the wall down into 2 fundamental pieces, the curtain wall units and the metal stainless steel panels that are applied to the curtain wall. Breaking that down, there were 2 separate activities, and you'll see in a second why. It made a lot of sense. And then the slide on the right is the composition with both of them on top of one another. From that point forward, in trying to control the cost and the fabrication and understanding how the wall system went together, we really studied what you can see, the little elements at the bottom were the different panel types. All varying in complexity and operable windows, fixed windows, shaped surfaces, etc. But that was a useful tool for us to be able to help control the cost, materials, etc. So from this point, moving it forward, the key here was to really, how do we produce this information, and we're able to package it up, document it, and release it for fabrication. This is where we all feel that we broke a lot of new ground, a lot of new territory, primarily with our help from Gehry Technologies. The parametric function in the script writing to develop a lot of the infrastructure to help us solve problems was enormous. Without that, we would have had a very difficult time actually assembling this project. What you can see from the slide is starting with the outside sculpted surface and then dealing with the curtain wall units behind that, bringing those 2 pieces together because they do need to work together, and you'll see in a second here how it does. We were able to start, this is a diagram on the left-hand side of one of the faces of the wall. through scripting, being able to run a script across the surface, essentially sets it up. The computer will set it up for us, which generates the facade. We then analyze the facade, and through the collaboration efforts with Permis Elise's team, able to really truly understand all of the different geometries and conditions that we needed to resolve and to come to grips with the final details. And obviously the optimizing was the end result of that, actually. And what you can see at the bottom are the mullion pairs that we started to look at. Every panel essentially facets, and then so that would be in the plan. And then in the section, we were doing some things where we did push the fun meter, where the actual curtain wall stack joints did not line up. And to have about 10,272 units where you had conditions where the stack joints did not align, that's a huge technical issue that was solved on this project as we move forward. Having all of the faces and surfaces essentially optimized and refined, which is what you see here on the left-hand side looking up the tower, that really generated everything else from that. The slab edges, the area of the building, the column, the structure. All of the columns tend to walk where they meet the perimeter. There are portions of the apartments that butt into the exterior wall, so there are bathrooms that every bathroom is slightly different, but we were all able to kind of organize and manage that and document that into a very solid package. And I'll get to that in a second. The surface was another kind of process, slightly different, but using the parametric tools and the scripting tools to get the architecture and the design intent that Frank was after. We kind of started off with two special conditions, a knife edge and a cylinder. And those two tools essentially make up the geometry for the entire building, along with a flat unit. And through the use of those two shapes, we were able to create the geometry. Here's an example of part of the parametrics, and what you can see is the white line, which is essentially the spline that runs up the column cover, has many pieces of intelligence to it. There are geometries where each one of the circles generates the radii for the specific cylinder along that column, and then it ties into each one of the spandrels. So if we're able to make changes to the geometry, we're able to reflect that into the facade spandrel pieces that tie into that, which is critical because every surface on the project was refined through the entire process. Every piece of stainless went through an exercise of refining the surfacing, so there were no mechanical deformation in the surface itself. And then it went into the window washing tracks that were all built into the system, which is the fuchsia lines off to the side of the column covers. Every window washing track was modeled with the geometry and placed into the design, which you'll see in a second here. Here's kind of a final result of standing on the 51st floor looking up the north facade. And what you essentially see on this slide, starting on the left-hand side are the flat corner column cover units with the operable windows next to them, a different unit type. And then adjacent to that are the radial column covers, the radial spandrels. You can actually see the window track that's built into the side of this column cover. And that races up and alongside the jamb of the column cover. Also, another good technical solution that we were able to achieve was the offset stack joints, where you can see the bay window here, and you can obviously see that they don't align where they do align up above. So these are just some of the major hurdles that we were able to accomplish technically through the development of the wall. Lastly, the other part that the computer and digital projects really helped us out with was all of the embeds. Every embed, there's I think about 13,000 embeds or so, was placed at the slab edge, coordinated with every aspect, column, heat pump, you name it. Everything that was essentially in the slab, on it, below it, we had in the model, and we're able to deal with technically and making adjustments as we needed to before it got to the field, which was huge. As I think Joe mentioned earlier, there were only about 4 or 5 embeds that were actually kind of off. We had, I think, through this whole process, maybe about 19 RFIs from permits to Lisa. It's just about controlling the information and vetting it before it leaves the office. It was incredible. Here's an image with the computer model laid on top of the actual finished structure. It's using Photoshop, we were able to align it up. It essentially shows you that the light blue lines with the embeds along the slab edge, how accurate things were able to be built and placed. Each one of the panels, each one of the embeds had its own address, an XYZ coordinate to place it. That was double checked and surveyed through the construction process. And I think, you know, having the belts and suspenders really paid off in a long way. Here's a kind of a final shot of the slab edge with the embeds placed on one of the facades. You can see the difference in the slab edges and the embeds as you go up the facade. The execution, which was very critical here in terms of a high-rise building. Essentially, each floor plate was overtaken by the unit layout, which you can kind of see here. So the sequencing with KBF, Sabara, the other trades was key in schedule, and that went as smoothly as the rest of the project, I have to say. Here's a quick shot of the installation of one of the panels. And then kind of a final shot here, which was a clean area in the building at the time here, which just shows you the complexity at the stack joint location with the faceting curtain wall with the undulating surfaces applied to that. And the window washing track actually in the foreground. Lastly, even another component is the tower crane, its tiebacks, the hoist, its tiebacks, all coordinated with the computer model placed. No hits. We were able to manage that as well. I mean, every level of detail that we could actually have input in and work with the contractor and the fabricators, it all ends up helping out the process. And here's, I'm just going to end up with a few final shots here up the side of the building. This is the east facade with the Woolworth building off to the distance. A shot here, one of my favorite spots to view the building is from Brooklyn and Dumbo, actually, just north of the bridge. Beautiful context with Woolworth in the distance. A sunrise shot from Brooklyn as well, which is probably the best time in the morning with the sun on the east facade. And lastly here, with the view from the 51st floor looking uptown to Midtown. I think that's it for now. I just really want to thank everybody. Permis Lisa, you guys were fantastic to work with. The engineering effort that you all placed into this was phenomenal. And likewise with Sabara. It was an incredible experience, up to a 2-day pour cycle at the top of the building with every floor plate different. Those folks need some credit. So through the process, I think just in closing that having gone to school here and been preached about the master builder, this is probably the closest modern day experience I think that you can get to it. It's not about having all of the knowledge, it's about using the knowledge and organizing it and being able to deliver it. So that's kind of where I am and how I came about this. It was an awesome experience. Thank you.